So continuing with 2.4 in college algebra, we're on 2.4b as in boy, page 219. We're going to look at example 2, which has a function g of x equals x squared over 2 minus 4x plus 8. So what they want to do is they want to find the vertex, axis of symmetry, maximum or minimum value, and then they want us to graph it. So we're going to complete the square. So in order to do that, we need to make sure that this part right here just is an x squared. So really, this is x squared over 2. We could actually write this as 1/2 x squared. So let's rewrite this as g of x equals 1/2 x squared minus 4x plus 8. And if we divide both sides by 1/2, or just multiply everything by 2, we can get rid of our 1/2 there. I think I'm going to follow what the book does, and just so you can follow that, because they don't really do either, but you end up doing it the same, or getting the same answer, so I guess it doesn't matter. So let's do what the book says. So what they do is they are just looking at the first two terms, because we're just trying to find the third term so that we can get completing the square. So what they did is they factored out a 1/2 out of the first two terms. So they did that, left with x squared minus 8x, and then they have plus 8. So notice what they did. They took the 1/2 out. So when they took 1/2 out, when we multiply 1/2 back times 8, we get our 4 back. So that's why I was saying divide by 1/2, which you invert and multiply by 2, and your 4 becomes an 8, and your 1/2 just becomes an x when you multiply 1/2 times 2. But we'll keep doing it the way the book does. All right, so at this point, we're going to look at what we have here in the parentheses and find a third term. So I'm going to drag along that 1/2, and I've got x squared minus 8x, half of that squared, plus 16. Okay, and then I've got, let me make that an equal sign, kind of looks like a minus. Actually, what did I add here? I added a 16 times 1/2, so I actually added an 8 to that. So that means that I'm going to have to take away an 8 and then put my positive 8 there. So now I have 1/2, and if I factor that, take the square root of x squared, square root of 16, put this sign right there, put a squared sign, and that equals my g of x. And I have basically a plus 0 here. I like to put the plus 0 there because that's my k. So that helps me as far as keeping track of what I've got there. So again, my vertex is going to be So my vertex is going to be 4, 0, okay, my 4, 0, my h and my k. And my axis of symmetry will be always my first point of my vertex, my x point. And my minimum, because the graph does this, okay, I know that it opens up, so I know it has a minimum value here. And my minimum value is my y value. Okay, so there's that information. So hopefully there's enough information there now that I can graph this without too much trouble. So let's go ahead and do that. So we said that the vertex is at 4, 0. So that's going to be there. We know it opens up. And we know this is our axis of symmetry. And at this point, that's pretty much all we've got from that information. But when you plot several points, meaning you make your table and you use your x squared over 2 minus 4x plus 8 and throw in different x values and spit out y values, you're going to get a graph that looks like this. Okay, one of the key things that you find is the y-intercept. So if you put in a 0 for your x, that will spit out the y-intercept. So that's a free point. So you put in 0 here, that gives you 0 minus 0 plus 8. So if your x is 0, your y is 8. Now one of the nice things about this is the reflection. So it's symmetrical. So we come over 4 that way, we go over 4 that way, and we get another point for free. So we've got those 2 points right there and right there. We have our vertex, and so then we can kind of get an idea of what this is going to look like, just given those 3 points there, since we know that it was an x squared, so we know it's going to be a parabola, and that'll make it easier. Okay, so again, and this is example 3, we're going to pull out the -2 of just the first 2 terms. In fact, I'm going to pull out that -2. That needs to be a negative sign. Alright, and then I'm going to put the minus 23 over 2 right there. Okay, so now I'm going to complete the square. So I'm going to have x squared minus 5x. Half of 5x is 5 halves. Square that, and we have 25 over 4 there. And again, notice that we added 25 over 4 times -2. So really we added -50 over 4. So now we're going to have to add 50 over 4 minus 23 over 2 from right here. So -2 times 25 over 4 meant we just stuck a -50 over 4 there, so we had to add it there to keep it legal. Okay, so then that gives me, let's just keep this as is, 5x plus 25 over 4, and then we'll have plus, and this will turn into 46 over 4, common denominator, which gives us 4 over 4, which is going to be plus 1. So then we've got -2, square root of x squared, this sign, square root of 25 over 4 plus 1, and that's squared. Okay, so from there we can find the vertex, and the vertex is going to be 5 halves and 1, and our axis of symmetry will, well, let's put my vertex is 5 halves and 1. My axis of symmetry will be the x value, and whether it's a minimum or maximum, it's going to be a maximum because the graph opens like that because of this negative sign up there, and the maximum value of my function is the y value of my vertex, which in this case is 1. So then you go ahead and graph it, and again what I would do when you graph it is plug a 0 in here for x so that you can find your y value, and you'll find that your y value will be your y-intercept. So then you've got your y value over here, your y value over here, your axis of symmetry, and you can kind of get an idea of what the graph looks like. So let's go ahead and draw this, and we end up with our vertex at 5 halves 1. And we found out that our zeros of our function, what makes, where does this cross and where does this cross? Well, we just put 0 in here and solve for the equation if that were 0, and we can find out where it crosses the x-axis. And so it's a little less than 2, a little bigger than 3 when you put the right numbers in there. And then you can find out where your y-intercept is. So if it's down here, you know that you have another point over here.